Happy Sunday, everybody. This is a live update with a 2-day severe weather threat about to unfold from the north central Gulf Coast region today, during the day today. More of a conditional severe weather threat, depending on if that warm front can migrate just inland a little bit. That could bring that threat across Mobile, maybe even coastal Mississippi, but probably southern Alabama into the Florida Panhandle maybe later today. And then the threat rapidly ejects on Monday through portions of the mid-Atlantic, and this is the area that I'm targeting. I was trying to decide whether to chase today or tomorrow, but tomorrow is just such a dynamically intense setup with the phasing of the southern and northern stream systems well underway by this time tomorrow. Today, though, you have more of just a southern stream system interacting with the subtropical jet with that strong flow extending downstream a little bit, but still more than sufficient low-level shear today, especially across the Florida Panhandle for a tornado and a waterspout threat that we're going to be watching very closely. But this is the event that I'm going to be chasing. These are the two different target areas during the day on Monday, and I see two different convective scenarios playing out. One mode is down here, extreme eastern North Carolina and the North Carolina Outer Banks, where there could be more of renegade clusters of supercell storms well out ahead of that front, mainly due to a jet entrance region that's going to migrate through the area before the remnants of the cutoff southern stream system eject off to the northeast through the mid-Atlantic. And at that time, late morning through midday, I do expect an arc of fast-moving supercells to develop across southern Virginia, maybe into far northern North Carolina, and then that arc is going to eject off to the northeast at about 50 miles an hour, maybe 3 or 4 different supercells within that line. It's also possible that there could be a QLCS type of a pattern with embedded tornadic circulations within a squall line lifting off to the northeast, and that could also arrive to the Delmarva Peninsula by Sunday late afternoon or evening. And eventually that convective line moves through New Jersey all the way through the New York City area. And the Storm Prediction Center actually has a 2% tornado risk all the way through the New York City area, including all of the mid-Atlantic. The Storm Prediction Center does have a 5% risk for tornadoes for this mode, which could begin as early as Monday morning. The HRRR is showing kind of these isolated renegade clusters of supercells lifting rapidly off to the north and to the northeast through eastern North Carolina, beginning as early as 8 or 9 a.m. By tomorrow morning. But the photographs don't look quite as favorable out here across far eastern North Carolina. The elevated mix layer, or that dry slot in the mid-levels of the atmosphere, doesn't arrive until Sunday afternoon out here in eastern North Carolina. So that creates a slightly less favorable situation across eastern North Carolina. But I do expect a secondary mode of supercells to develop along that front. South central Virginia, north central, northeastern North Carolina, and that's going to lift rapidly off to the northeast. And honestly, forecast soundings and photographs look a little bit more favorable for this northern mode. Big monster elevated mix layer builds in the wake of that initial mode across eastern North Carolina. That's going to be well over the Gulf Stream by the time this secondary mode fires. But I can see a couple supercells developing as early as 10 or 11 in the morning across south central Virginia, north central North Carolina. And I have seen some discussion online about whether weaknesses in the mid-level shear within the mid-levels, not the bulk shear sense, if that could lead to a reduction in the deviant storm motions of the right-moving supercells. In my opinion, especially based on the data that we collected from the rocket launch into the Linwood, Kansas EF4 tornado from 2019, is that the mesocyclone has a very different structure in the mid-levels of the atmosphere than a low-level mesocyclone or a tornado cyclone would in the very low levels of the troposphere. In the mid-levels of the atmosphere, the mesocyclone definitely stretches out as it goes upward, basically becoming more of a tilted vacuum cleaner in the mid and upper levels of the troposphere. And that's why I feel that mid and deep layer shear in a bulk sense from the surface or lower levels of the troposphere, maybe the top of the low-level jet, up through the mid and upper levels of the atmosphere, is more relevant in a mid and upper level shear sense to drive those right moving storm motions or those right moving supercells that really ramp up that storm relative helicity and help ensure that you get supercellular storm modes out here. Another mechanism where you can force that deviant motion is if you get more of a quasi-linear convective system, basically a squall line, where the large-scale outflow of that line drives a more right storm motion, basically a deviant effective storm motion for the individual convective elements, and then you can, for a short time, for a transient time, you can really blow up that storm relative helicity, and that causes the development of those tornado cyclones within a convective line, really forcing more of a deviant storm motion relative to the mean wind from the low levels through the upper levels of the troposphere. But getting those deviant storm motions is definitely important, especially in those weaker mid and upper level flow cases. In this type of a situation where you have stronger synoptic scale forcing, stronger kinematics, stronger wind fields from the low levels through the deep layer, you definitely have those soundings with a more shallow critical angle favoring tornado production across the eastern U.S., and that includes here in the eastern Carolinas, across portions of the mid-Atlantic. Usually you get more of those shallower critical angles, stronger low-level shear, more of a contribution from the speed shear part to the low-level shear equation out here in the eastern U.S. as opposed to the tornado alley, or especially the high plains where you get those easterly winds up through a couple of kilometers and then flipping around to westerly aloft. So you definitely need to look at each different region with a different set of rules. In the high plains, you have a very different pathway to arrive to those favorable conditions for tornadoes than you would for a mid-Atlantic setup like this. But either way, the elevated mixed layer, that dry air coming into the mid-levels of the atmosphere, is very important to generating wind shear. Getting those breaks in the clouds and that dry air coming in over top that moisture is definitely a huge part in getting those supercell storms to develop. And I think that there's a much more stout of an elevated mixed layer for this northern mode. This northern mode is a little bit later timing-wise, so that dry air is going to come in the mid-levels of the atmosphere, overtop that moisture, lead to an arc of supercell storms embedded within relatively sunny skies, and that's going to be a fast-moving arc of supercells, or a quasi-linear convective system that's going to race off to the northeast, eventually through southern Delmarva, and maybe even up toward southern New Jersey as well. And but initially, this first mode in far eastern North Carolina could begin as early as daybreak tomorrow morning. So this is going to be a very quickly evolving setup, but this is the focus on Monday, and there is a chance of severe weather today, and the Storm Prediction Center has a very large slight risk area. As you can see there, that slight risk covers much of the central Gulf Coast, basically to the east of that surface low, through the Mobile area, Florida Panhandle, southern Georgia, and eventually for overnight tonight, late night tonight, coastal South Carolina and North Carolina is included in that slight risk and that 5%. But that's more for that early mode that I just showed you in green across eastern North Carolina. And I don't think that that really begins until probably a daybreak Monday type of a situation, maybe late night tonight, but probably a Monday morning type of a situation with those renegade clusters of supercells moving over coastal North Carolina and the Outer Banks region there. But now I'm going to break down the pattern phasing, kind of the synoptics of this system. We did this yesterday, but we'll do it again today. This is the NAM model right here on the pivotalweather.com website. And you can see that southern blob down there. That's the southern stream system. That's centered over the Red River region right now, over southern Oklahoma. You can see that subtropical jet connection right here. So you basically have two different jet streams. You've got the polar front jet stream to the north. You've got the southern branch. This is the subtropical jet stream to the south. This has origins in the subtropical Pacific and the tropical Pacific, where you get the La Nina and El Nino events that we talk about so often these days in a sea surface temperature anomaly sense. Right now we do have a weak to moderate La Nina out of the tropical Pacific, and that's likely going to bleed into the spring months, continue through this winter into the spring. And that's why I do think that Dixie Alley is going to come to life during the spring months coming up here in 2021. Similar to about 10 years prior, 2011, we had a much stronger La Nina in the tropical Pacific during the winter, and that bled over into the spring, leading to some very prolific severe weather events in the spring. You had a very consolidated jet, polar front jet then, a lot of open waves, a lot of massive open storm systems progressing across the country from west to east, and that includes the April 15, 2011 outbreak, where over 100 tornadoes happened across the lower Mississippi River Valley through much of central Dixie Alley, and also the super outbreak, of course, April 25th, 26th, and 27th from the southern plains across Dixie Alley. I'm not going to say that's going to happen again, but usually La Nina events lead to more of a clean jet pattern in the spring months across the United States with these large open waves in a very progressive pattern moving from west to east across the U.S., whereas El Niños, you usually get this split flow pattern extending through the late winter into the spring, which can lead to some pretty active Dixie Alley events during the winter months into the early spring, whereas La Nina, Dixie Alley seems to start a little bit later in the spring months, more of an April, late March into an April type of a pattern there in Dixie Alley, whereas El Nino events, you usually get an earlier period of Dixie. This pattern right here is a little bit more reminiscent of an El Nino pattern with an energized subtropical jet down here, split flow pattern. You've got a cutoff system in the southern stream moving across the southern plains. You've got this system positively tilted in the polar front jet. This is going to become the dominant trough eventually, and then the remnants of this cutoff system are going to surge to the east along with that surface low as well through southeastern Virginia, eventually into the mid-Atlantic up toward New York, and that's going to happen very fast. As we go toward midday today, you can see the southern stream system begins to eject, really maintaining its strength because of its interaction with a subtropical jet. You get a lot of cyclonic shear vorticity at the base of these troughs, these cutoff systems. So when you get an energized subtropical jet like this, or an El Nino pattern, that often leads to these cutoff systems diving south into the southwestern U.S., dumping a lot of snow into the southern Rockies and the southern mountains out here, mountains of northern Arizona, New Mexico. That's why you get a lot of snowstorms in the southern plains, or you can get more snowstorms in the southern plains with a very energized subtropical jet digging those storm systems down over the Rockies in the southwest. This is kind of a weird El Nino pattern within a general La Nina pattern, and I suspect as we get toward the middle of December, we'll return to that warm southeast, cold northern plains traditional La Nina pattern, but there's a lot of warm sea surface temperatures in the northeastern Pacific also that are helping to excite this ridge across the western U.S. But this is a classic phasing of northern and southern stream systems, and this low, because of its interaction with a subtropical jet, is going to send a lot of strong mid and upper level flow well downstream of this upper trough, and that's why the severe weather today is going to be focused from coastal Mississippi, coastal Alabama, through the Florida Panhandle. But anytime you get these coastal fronts hugging the northern Gulf like this, if there's an abundance of convection or rainfall, then it'll cause that coastal front to remain just offshore, and that'll cause the tornado and the waterspout potential to also remain just offshore during the day today. But looking at the latest RAP model, it does look like there's going to be enough of a low-level jet. This system intensifying as it ejects from the southern plains, moving into Dixie Alley. So I do think that surface-based instability is going to bleed just inland into the southern Gulf of Mexico, including coastal Alabama and the Florida Panhandle with this event. Here you can see that low-level jet really ramping up as we go through 21Z across coastal Alabama and western Florida. A low-level jet of almost 50 knots out there. And looking at the forecast NAM sounding, you can see that the coastal front is just offshore according to this NAM. That's why we have more of a marginal severe weather threat indicated here. A little bit of an elevated mixed layer just starting to move into the central Gulf Coast here in the NAM. We'll look at the HRRR though to assess and the RAP model to assess the detailed tornado threat here today across the central Gulf Coast. But that's a surprisingly strong low-level jet ahead of that intensifying southern stream system just as the phasing process is about to begin. And that strong low-level jet by about 0Z dominates southern Alabama, west-southwesterly low-level jet there. But it all depends on how far inland that coastal front and the surface-based instability with it bleed inland a bit. That's looking at 850, so I want to show you this phasing of the system. Here you can see the northern stream trough starting to dominate. It's got a lot of flow on the backside, which means that it's still intensifying. It's got this positive tilt. It's about to gain a negative tilt, and then this southern stream system begins to weaken, and as the northern stream system starts to dominate. But I believe that yesterday the NAM was accurate and having the southern stream system maintain its identity for a little bit longer, almost as a acceleration in the low-level jet as it lifts through the mid-Atlantic, lifts through Virginia toward the Delmarva Peninsula. And that appears to be exactly what's going to happen with the HRRR, definitely picking up on that. This is 3Z tonight, so this is about 9 p.m. tonight, and that southern stream system and the stronger flow downstream of it start to move over top the wedge or the cold air just to the east of the Appalachian Mountains. And as that low-level jet accelerates, it's going to lead to rapid destabilization to the east of the Appalachians, and that's going to begin tonight. By tomorrow morning, there's likely to be a big-time low-level jet cranking from south to north just to the east of the Appalachians. And it's really the emergence of this lead jet streak well in advance of the remnants of that southern stream upper level system. This is what could, in the entrance region to this jet streak here, could help to accelerate these prefrontal storms, some enhanced convergence as well along the eastern North Carolina coast there from that ramping up low-level jet. Could develop an early mode of even tornadic supercells here across far eastern North Carolina, maybe even Virginia Beach area, coastal Virginia, and then that moves out over water by late morning or even by midday. But I've had to decide whether I'm going to chase eastern North Carolina by tomorrow morning, or do I want to position near the Virginia-North Carolina border out ahead of the remnants of this southern stream system, where I do expect a little bit more backing of that low-level jet. I do expect the arrival of the elevated mix layer to arrive out there as well. And looking at the upper level moisture here, you can certainly see where the elevated mix layer is on the NAM. And this is at 12Z, and you can see that the elevated mix layer just hasn't quite arrived yet out here in coastal North Carolina. You can see the hint at some prefrontal convection grazing by the Outer Banks by about 8 or 9 a.m. tomorrow morning. Could be some supercell waterspouts ripping by at about 50 knots. But the arrival of this elevated mix layer here, this slug of dry air coming in at the mid-levels of the atmosphere, I believe that this is going to be crucial to develop severe weather, and that's going to happen in an arc here, developing first across south central Virginia, Monday at about 10 a.m., north central North Carolina up here, and then that's going to lift rapidly off to the northeast, but certainly aided by the arrival of this elevated mix layer with this southern stream system basically transporting this descending, dried out air on its backside all the way through Dixie Alley and then arriving here east of the Appalachian Mountains. This is mid-level dry air, easily can clear that mountain range, and then you're going to have a low-level jet accelerating to the east of that surface low here. Look at all this diffluence too, well to the east of this evolving, phasing upper-level pattern here. That's also going to aid in the development of some prefrontal renegade clusters of supercells across far eastern North Carolina and the Outer Banks about 8, 9, 10 a.m. tomorrow morning. And this is by 15Z. You can see that that elevated mix layer has punched all the way up into southern Pennsylvania there, dominating the whole entire state of Virginia. And you can kind of see the hint, this arc of supercells that's going to develop even in the relative humidity fields here in the mid-levels of the atmosphere. It's going to be right along this convective line where I do expect supercells to develop right in the heart of that elevated mix layer, which eventually arrives to the North Carolina Outer Banks by midday. So it's possible that you could get a reinvigoration of those renegade clusters of supercells ongoing there in eastern North Carolina by late morning, approaching midday before they go offshore. But really this pronounced elevated mix layer taking over the entire mid-Atlantic. This is going to signify the arrival of severe weather too for the New York City area, Long Island. This definitely could be a severe weather event that extends all the way up to the New York City area by late afternoon and evening with this elevated mix layer lifting way off to the northeast. And let's see how the instability responds, at least here in the NAM. And then we're going to break down the HRRR model. And then I'm going to share with you my storm chasing plan. So here's the NAM building about almost 500 to 750 Cape all the way through the Delmarva Peninsula beneath this elevated mix layer. Even arriving into portions of southern New Jersey there. Let's look at a forecast sounding here in Delaware. Tornado sounding. Big low-level shear vector, 0 to 1 kilometer shear vector. Basically, you got about 18-knot southerly surface wind there. 50-knot, 1 kilometer wind. A little bit of directional shear too, but that's at least 30 knots of 0 to 1 kilometer shear. And then you've got a little bit of 2 to 3, strong enough 2 to 3, 4, 5 kilometer winds to evacuate that rain from the updraft, the rain and the hail from the updrafts. And I do think there's going to be hailers also of these with such a stout elevated mix layer. And here you can see that big dry slot that comes in the mid-levels of the atmosphere. That's going to be crucial for steepening these lapse rates. This is kind of an unusual deal here. This warming between 500 and 700 millibars, that certainly could lead to a reduction in the convective coverage there across eastern North Carolina. And then by 0Z, basically all the instability is pinched off over the Gulf Stream there, at least according to the NAM. But let's go back to today and analyze the evolution of this coastal front on the RAP, and then we're gonna check out the hodographs and differences in the soundings and hodographs between the two different target areas between Monday morning and eastern North Carolina and that arc of supercells into southeastern Virginia. But today, here is this coastal front. Here's the surface low located across southeastern Louisiana, subtle surface low. And the coastal front could lift onshore just to the east of that surface low. Here's the coastal front, basically following the edge of the terrain. Here's Venice down here where we wrote out Hurricane Zeta. And then you can see the surface-based instability basically following the coastline here with that coastal front just offshore the Florida Panhandle. This is the 16Z analysis by the RAP. And by midday, by 18Z, this is the 2-hour forecast. You can really see that surface-based instability invade southeastern Louisiana there, with some surface-based convection starting to develop across southeastern Louisiana. There's some decent storm relative helicity there too. And you can also see the coastal front starting to lift closer to Mobile with some surface-based instability lifting just onshore through Mobile Bay, including downtown Mobile. And that lifts to the north just ahead of that surface low, aided by that 40 to 50 knot low-level jet pop that was depicted by the NAM model. And then that coastal front lifts onshore by about 21Z. That's probably 3 or 4 o'clock there in the Florida Panhandle. Portions of the Apalachicola there, the Big Bend region of Florida. It looks like you're getting surface-based instability with due southeasterly surface winds, so some enhanced low-level shear down there as well. So I do expect some water spouts to come on shore there. Pensacola, back toward Panama City, eventually down toward the Big Bend region of Florida as well as you go toward late afternoon, closer to evening. Southeastern Louisiana certainly does have a chance too, but this is that surface-based instability, basically where that Cape gradient just emerges onto the central Gulf Coast there from Mobile east. And the wind shear with that low-level jet acceleration. Look at that, 300 to 400 effective storm relative felicities across southeastern Louisiana in about 2 hours by midday. And that's when surface-based storms are also going to be developing down there in southeastern Louisiana. Could definitely be a water spout day on Lake Pontchartrain today. And that shear ejects east with time by about 20Z by 3 p.m. Strong wind shear begins to move onshore in the Mobile area by early afternoon. Also the western Florida Panhandle starts to get that wind shear moving onshore. And the RAP model is very good at resolving the onshore migration of these coastal fronts and its response to an accelerating low-level jet. And you can certainly see the low-level shear ramp up as that surface low ejects to the east. There you can see that surface low gradually strengthening just a bit also as it moves off to the east. That's as the upper level system is also intensifying overhead as it interacts with the subtropical jet along its southern flank, enhancing that shear vorticity. This is the surface pressure response. But you can certainly see those backed winds. And let's see if the rapid model has as strong of a low-level jet as the NAM. And it certainly does, up to about 40 to 45 knots, all the way lifting up into the southern half of Alabama, western Florida, the Florida Peninsula. So that's why we've got a 5% tornado threat today from southeastern Louisiana across coastal Mississippi, southern Alabama, even the Florida Panhandle there. And then all of this ejects off to the northeast, and then the threat shifts to eastern North Carolina Monday morning for renegade clusters of storms, and then the development of an arc of fast-moving supercells, or a QLCS pattern, from south central Virginia into maybe far northeastern North Carolina tomorrow afternoon. And that's the mode that I'm likely going to chase. I could have gone all the way down to the central Gulf Coast for this setup and then just chase this whole entire system east along coastal Mississippi, Alabama, but then I'd have to drive all night and somehow get to eastern North Carolina by Monday morning. Maybe up there, south central, southeastern Virginia, near the North Carolina-Virginia border seems like a little bit easier of a trek up there. So now let's go back to Monday again. And these are the two target areas for Monday. I expect the development of two different convective modes. I'll probably target this region down here, just to the east of the Danville area in south central Virginia, maybe to the northwest of Raleigh. And I think that this mode is going to lift northeast through southeastern Virginia. Richmond probably should keep an eye on this mode as well. And this is going to be the earlier morning mode. And let's look at the different photographs between these two areas. So here is the Monday morning photograph in eastern North Carolina. First glance certainly does look conducive for a tornado threat. You can see that the critical angle is just a little bit more shallow there than what you'd see in a traditional high plains or a tornado alley type setup. This is that critical angle. This is the storm motion for the right mover. This is the left mover. And of course the mean wind right in the middle there, mean storm motion. And usually when you get these very synoptically active or kinematically strong setups with very strong wind fields from the lower troposphere all the way up through the tropopause, the right mover is a little bit closer to that of the mean wind, so you get less of a deviant motion. But in my opinion, with mesocyclones, the magnitude of this deviance is more dependent on the bulk shear from the low levels of the troposphere through the mid levels of the atmosphere instead of the shear within that gap between about 3 and 5 kilometers. I think usually you don't see a lot of shear between the mid levels of the atmosphere like that. And the reason I believe that is because I believe that the mid-level mesocyclone is very different in structure to the low-level mesocyclone or the tornado cyclone at the very low levels of the troposphere. I think that it's easier to maintain a more compact vortex in the lower levels of the troposphere in terms of force balance. And then as you go up into the troposphere, I believe that it rapidly widens, becoming more of a tilted vacuum cleaner effect into the mid-levels of the supercell storm. And we confirmed that by launching rockets into the Linwood, Kansas tornado. You basically have this tilted vacuum cleaner existing as the mesocyclone above, and then any eddy underneath that basically may be caused by the propagation of the rear flank downdraft beneath that tilted vacuum cleaner. Any eddy beneath that mid or lower level mesocyclone is a candidate to be stretched and become a tornado. And in this case, I think that you've got plenty of strong mid and upper level flow to evacuate the rain and the hail from the updraft. And then you want to set your sights on the low level shear and the orientation of those right moving supercells relative to that wind shear. And usually in the eastern U.S., you can get away with having a more shallow critical angle, and much of your low level wind shear is contributed by speed shear instead of directional shear, as is often the case in Tornado Alley and the high plains. And with weaker mid and upper level tropospheric winds during the spring and the summer, as you usually get across Tornado Alley and the high plains, then you can get more deviant storm motions with that propagation term dominating over the contribution from the average mid and upper level flow in the environment in which the supercell is embedded. But this photograph here definitely looks supportive of a tornado threat, including water spouts. You've got a lot of positive storm relative helicity within this area, even with these rapid northeasterly movers at about 40 miles an hour. But I do think that the photographs become a little bit more favorable further west with the arrival of the remnants of that southern stream system, looking a little bit more like that with that stronger 1 kilometer flow here in eastern North Carolina. By Monday morning, you have a low-level jet of about 40 knots, but it accelerates above 50 to even close to 60 knots as you get closer to that surface low that's going to be ejecting up the spine of the Appalachians. A very rare surface low track, but really driven by the phasing of the southern stream system and the northern stream system, and the dominance of the system in the polar front jet stream, with the southern stream system basically lifting up on the east side of the warm sector of the newly dominating parent upper level system in the northern branch. So now let me show you the hodograph. Well, first we'll look at the sounding here in eastern North Carolina. This is the forecast sounding from the HRRR. And this shows you that the elevated mix layer has not yet arrived in coastal North Carolina, where these supercells are going to be located. It does arrive, though, by late morning, closer to noon. So if there are some prefrontal clusters of supercells in eastern North Carolina, I think that they're likely going to be enhanced by the arrival of that elevated mix layer. But you can see here it's still quite moist in the mid-levels of the atmosphere. A little bit of a dry slot there at about 3 kilometers up. Plenty of moisture, though, to get those cloud bases very close to the land or the ocean surface there in eastern North Carolina. But very skinny Cape. The steep lapse rates haven't arrived yet because the elevated mix layer hasn't arrived yet. But you still can't ignore that very strong low-level shear out there and favorable hodographs for water spouts and supercell storms of that prefrontal cluster. But the late arrival of this elevated mix layer and the steepening of those lapse rates that's going to happen across southeastern Virginia and far northeastern North Carolina, I think is going to be key for this severe weather event. And here is that elevated mix layer. Watch the drying out that happens in the mid-levels of the atmosphere with the arrival of this monster EML. That's a dry slot coming in the mid-levels of the atmosphere. Basically like a rear flank downdraft in a synoptic scale sense, but that dry air comes in the backside of these troughs. And since it's moving faster, with that faster mid and upper level flow, it advects over the warm sector and over the heat and the moisture at the low levels of the atmosphere in the warm sector, and that helps to steepen these lapse rates. So you can see that the Cape axis is quite a bit steeper up here. This sounding is from southeastern Virginia, ahead of that convective line that should develop by about 11 a.m. or noon, south central Virginia. You have a slightly lower dew point. These surface temperatures, though, will likely be into the low 70s with the breaks in the clouds aided by this elevated mix layer. A little bit of directional shear here in the low levels, but mostly speed shear is a contribution, and that is often the case in the eastern U.S. with these tornado events. And here in the mid-levels of the atmosphere, plenty of strong winds. But to get those deep mesocyclones, I believe that you just need a wind shear between the mid-levels of the atmosphere and the low levels, and you do have some directional shear going from a due southerly, relatively weak surface wind to a southwesterly wind at about 60 knots at 500 millibars. And you also maintain this low-level jet despite the advection of this very strong mid-level clear slot coming in at 500 over the area. So that's why I would target the mode there in southeastern Virginia. And let's look at the wind shear. Even the hodographs are more favorable as you get an increase in that 1 kilometer wind to over 50 knots. So you kind of have a more classic sickle shape to the hodograph, and you can see this low-level wind, the 1 kilometer wind, increasing to up to 60 knots, and almost a due southerly low-level jet ahead of the remnants of that southern stream cutoff system that are ejecting off to the north and eventually to the northeast in the warm sector of the new parent system. Surface wind due southerly, even a little bit east of due south at about 15 knots. And that creates nearly 40 knots of low-level shear. So even if you have more of a skinny convective line, it's likely going to wrap up tornado vortices in there. And those convective lines and the outflow associated with it can also encourage a more deviant storm motion for the convective elements that comprise that QLCS system. And so that's why you often get tornadoes, an increase in the tornado occurrence within a linear convective line as opposed to more of a supercellular mode earlier in the day, and that's because that convective line forces a more deviant motion of the individual convective elements, and it's also because overnight you usually get an increase in that low-level jet and an increase in the low-level shear, which is proportional to the area between the hodograph curve and the storm motion vector, which that right there is the right mover. And again, I have seen a lot of discussion that there's not a lot of shear within the 3 to 5, 6 kilometer layer. But that's often the case. You often get strong flow at the mid and upper levels of the troposphere, and I believe that really it's the difference between the wind shear between the lower troposphere and the mid and upper levels of the troposphere. You can see there's some directional shear there also some speed shear, and that's going to be enough deep layer wind shear to encourage a deep mesocyclone and a sufficiently deviant storm motion to realize some storm relative helicity that definitely could lead to a tornado threat. So that first photograph I showed you is for this mode down there in eastern North Carolina in green. That's the Monday morning mode. More of a conditional tornado threat, but definitely still could get some water spouts and some tornadoes down there with those renegade clusters of storms, basically associated with the right entrance region of that jet streak that's lifting off to the east. And then you've also got this mode. That's what the photograph I just showed you. Strong elevated mixed layer, steeper lapse rates, maybe more supercellular modes, more deviant motions. And for that reason, that's why I'm going to target this area in southeastern Virginia and track it as far northeast as I can before retreating back to my mom's place. But I've still got the whole day today to decide which one to go after. So now I'm going to show you the HRRR solution here. And the evolution of convection. I usually look at this last. I like to look at the environments initially that these storms are going to be embedded within. Try to get a feel of the synoptics all the way down to the smaller scale features. All right, so here's the HRRR. And this is surface-based Cape. This is at 4Z tonight, so this is getting a little closer to midnight. You start to get some surface-based instability bleeding onto coastal southeastern North Carolina. But really the surface-based instability doesn't arrive until about 11Z, 11 to 12Z, 7, 8 in the morning. And the Outer Banks, you start to get capes in excess of about 1,000, even back toward Cape Fear. Some decent capes focused right along the coastline. And it's this area here, this surface-based instability, that bleeds onto coastal North Carolina that could make that early mode possible, the Monday morning mode here. You could definitely see these little holes in the Cape. Those are little convective elements, surface-based convection, renegade clusters of storms, really fueled by the lift from the entrance region of a mid and upper level jet streak that forms late night tonight through tomorrow morning. And also some convergence along coastal North Carolina from the land-sea interface here as that low-level jet accelerates. That's also going to help to develop this prefrontal renegade zone of storms. And here's the low-level jet. This is a kilometer up above the ground, and this is 15Z, so this is mid-morning, tomorrow morning, mid to late morning. And you've got a 55 to 60 knot low-level jet here across coastal North Carolina. Here's the 850 low over the central Appalachians. Basically the remnants of the southern stream system there. So these storms are going to be embedded within a strong low-level jet. And the HRRR is definitely showing these clusters of renegade storms to be ongoing tomorrow morning across the North Carolina Outer Banks. And by this time, late morning, you've already got a broken line of supercells starting to form across north-central North Carolina into south-central Virginia, maybe near the Danville area by tomorrow morning. There you can see the HRRR is even trying to show some bean shapes, supercell modes here across south-central Virginia into northeastern North Carolina. And even by 16Z, about 10 a.m. out here, you've still got renegade clusters of storms across eastern North Carolina, fueled by the convergence of the land-sea interface here. Also a jet dynamic structure. You've got the entrance region of a mid-level jet lifting off to the northeast here through the mid-Atlantic. You've also got positive vorticity advection with the evolution of this coupled eastern U.S. trough here. So there could be some tornado warnings, definitely some special marine warnings with these storms as they rip by coastal North Carolina. But based on this, I think I'm going with the elevated mix layer that arrives out here across Virginia, south central Virginia there. That's the elevated mix layer I'm talking about. It's going to be some snow over portions of northwestern Ohio, and then as this system lifts by, you're going to transition to a northerly lake-enhanced and lake effect event across northeastern Colorado, the Erie, Pennsylvania area, the higher terrain. Got the development of a northerly lake effect event off the end of Lake Michigan here. Winter storm watches are in place across northwestern Indiana for that, including South Bend. Those are always big events in the early season when the lake temperatures are so warm and you get convergent flow around the diabatic heating max over the lake. That focuses a single lake effect band down the middle of Lake Michigan, just hammering northwestern Indiana there. And here's the surface low, a 993 low over Shenandoah National Park, basically by 17Z tomorrow, midday, with a broken line of supercells possible into southeastern Virginia, maybe down into northeastern North Carolina there. Still some clusters of renegade convection happening there along coastal North Carolina. These are definitely going to drop some water spouts out there. And then the elevated mix layer starts to arrive here by about late morning, 10 or 11 a.m. So probably will be a reinvigoration of these renegade coastal storms along the outer banks of North Carolina. Looks like these are going to stay just offshore of Virginia Beach possibly, but I wouldn't be surprised to see a couple of these even a little bit further west, Nags Head up toward Virginia Beach. But then we start to get the development of this mode, south central Virginia. And this could influence the Richmond area, some populated areas there of southeastern Virginia, maybe down as far south as Raleigh. Looking at the forecast sounding down at the tail end, you start to get some skinnier critical angles there as you go further south, but better moisture, 2 points near 66, temperature 70. Pretty unidirectional low-level profile. A lot of speed shear, though, showing about a 35 knot, 0 to 1 kilometer shear vector there. But then a little further north into southeastern Virginia, you get a little bit more of a favorable hodograph shape with more of these easterly winds between the surface and 500 meters. More saturated, though, low-level profile, showing some cloud cover despite this dry slot coming in, this stout dry slot coming into mid-levels of the atmosphere. And it still is a pretty shallow critical angle there. But usually here in the eastern U.S., critical angles are a lot more shallow like that, but still that is pretty shallow critical angle. And as we go toward about 1 p.m. Eastern Standard Time, got a broken line of supercells, maybe a QLCS pattern moving through southeastern Virginia, eastern Maryland. And it does eventually arrive to Delmarva by mid to late afternoon. And look at those renegade storms just hanging on in the North Carolina Outer Banks, even through 19 or 20Z. And in fact, you get a merger of the two different modes that we identified in the target area. You get a merger of the broken line of storms along the front with this renegade convection as the elevated mix layer catches it. And then finally that convection moves offshore, and then you've got this QLCS pattern invading Delmarva Peninsula by about 20Z, 3 to 4 p.m. on Monday. Wouldn't be surprised to even see a couple tornado warnings with this warm front that lifts all the way up north toward New York City. Kind of a diffuse warm front, but there could be some surface-based instability even up toward the New York City area by late afternoon. Look at this moisture axis hanging on coastal Virginia, northeastern North Carolina. But whenever I'm forecasting, I try to look for reasons why tornadoes are going to happen. I forecast from the storm chaser perspective. Many meteorologists there, armchair quarterbacks, Monday morning quarterbacks like to look for reasons why an event might not happen, because then you can look back a day or two later and say, see, I was right. But really most of the time, tornadoes don't materialize, but you try to look for those worst case scenarios out here, the most damaging situation that could happen. And there certainly could be some damaging tornadoes with those with the magnitude of the low level shear expected, and such a dynamic system, so strong kinematically out there. And then after that, severe weather moves off the coastline Monday evening into Tuesday. That's when we could get some decent snow along the spine of the Appalachians there. Southern Appalachians, there you can start to see that snow begin to ramp up, especially Monday night. And you get a fetch off of Lake Michigan all the way to the western slopes of these Appalachians. So you're actually talking about a lake-enhanced event here, basically a lake effect event across the Appalachians. You can get hammered on the western slopes of these Appalachians. areas like Gatlinburg, Smoky Mountain National Park, Grandfather Mountain out there. It looks like it's going to have that perfect fetch downstream from Lake Michigan to just hammer that area with snow. Let's see what the NAM is showing. And that starts to shut off by Tuesday morning. But Cleveland, Erie gets hammered. Starts getting hammered by then. And the NAM is definitely showing 5, 6, 7 inches of snow, maybe higher amounts on those western slopes of the Appalachians there. Smoky Mountain National Park, Smoky Mountains National Park forest out there. And up here in West Virginia, along the spine of the Appalachians. And the models are definitely coming down a little bit as compared to those earlier GFS runs that were showing like 1.5 feet of snow across northeastern Colorado, but they still are showing that across the higher terrain in the Erie, Pennsylvania area, across Mayville, New York, far western New York there, the higher terrain of the Chautauqua Plateau always gets hammered. So it looks like that lake effect is going to continue through the middle portion of next week. Also, southern Ontario is going to get blasted by this. The NAM model shows about 3 to 5 inches of snow for the Detroit area. Even Toledo gets a little bit in on the action. Some of the higher terrain down in southwestern Ohio could get several inches of snow, according to the NAM. And most of the models now are coming into agreement here. Cleveland still looks like the lucky winner in terms of snow, getting the most from the Synoptic side, the lake enhancement and the lake effect snow. Cleveland to Erie, especially the hills just inland from the Lake Erie shoreline there, and Erie's definitely going to get hammered. 6 to 8 inches here across the beautiful southern Appalachians, straddling the Tennessee-North Carolina border is also going to be interesting. So we've got a lot of things to watch, and I've got to decide whether I'm going to chase mode number 1 or mode number 2 here. And I've got the day today to decide through tonight's evening model runs. And I'm also going to be monitoring the central Gulf Coast for that tornado threat, with that low-level jet increasing to about 40 knots across coastal Mississippi, Alabama, and then eventually that threat shifts toward coastal North Carolina and South Carolina here during the day today. And I'm also going to try to get my live stream going too for storm chasing. Got a new Verizon card, so I'm going to try to stream to both Facebook and YouTube during this storm chase. And that includes not only the severe weather tomorrow, but also those snow squalls that are going to be impacting the higher terrain in the Smoky Mountains up there along the border of North Carolina and Tennessee. So that's that update. I hope you guys enjoy my weather reports. That's really the thought process that I'm going through as a storm chaser, to try to decide whether I'm going to chase or not and where I'm going to chase, and also what extreme weather phenomenon I'm going to chase, whether it be the severe weather and the snow in the mountains or just the snow. I'm also trying to get my mom to go on the storm chase with me, see if she'll go, or if she's going to stay here with Gizmo, or if Gizmo's going to go, if we're all going to go at the same time. So those are the types of decisions that I'm making here. I was up late last night watching that Mike Tyson boxing match, which was really a complete waste of time. I definitely got duped by that. Looked like kind of a money grab to me, but definitely a bizarre event to watch. Definitely entertaining as well. I enjoyed Snoop Dogg, Wiz Khalifa last night. But it sure seemed like Tyson should have won. I don't think that the draw kind of confirms that was probably more of a gimmick. But it definitely looks like Mike Tyson's ready for real action to me. Whereas Roy Jones looked more like me with my shirt off. So I'm likely going to be activating chase mode, maybe leaving at about 3 in the morning, depending on which mode I select. I'm about 5 hours from the Outer Banks, but about 3 to 4 hours from the North Carolina-Virginia border to catch the mode fueled by the elevated mix layer. And eventually these two modes, the green and the blue, kind of merge there along coastal Carolina. It's going to be a fun day to be in the North Carolina Outer Banks, that's for sure. If you have a stilt home in Cape Hatteras, definitely keep your eye out for a passing wall cloud ripping by at 40 or 50 miles an hour. Maybe a landfalling water spout out there. Definitely an interesting day to be a weather enthusiast. So thank you, everybody. Thank you, Facebook supporters especially, for making live storm chasing and these live severe weather briefings possible. I'm going to start to do the storm chasing school here as I'm at my mom's place once we get into this cold pattern ahead. And I'm going to start breaking down case studies, more meteorological, educational content, and I'm going to make that available for Facebook supporters on here, at least in a live sense. But thank you, Facebook supporters, for making our science possible, making live storm chasing a reality, making these live briefings possible so that I could chase everything and break everything down nationwide and not be at the mercy of a big corporation out there. So thank you, everybody. Never stop chasing, and I hope that you enjoy my weather reports.